Welcome to 3D Printing 101, our 3D Printing Introduction series. Last video, we went over what is slicing software, and the Cura walkthrough. This time, we're going to check out printing settings. And next time, we're gonna check out the actual print. So let's get going. Alright, so now let's talk about print settings, right? Over here. Let's start with layer height. So layer height is going to be the height of each one of the individual layers as you print your model, right? For the most part, you're probably going to be orbiting around 0.2 millimeters for a desktop FDM printer. This is going to give you a relatively decent resolution. You know, it's pretty good for models that don't require really fine interlocking or really fine details like faces and stuff like that. If you want a little bit more detail, you can go down to 0.1. If you want to tinker with your printer even more, you might be able to get finer details with a thinner nozzle, etc., etc. But for now, you know, you're probably going to switch between 0.1 and 0.2 millimeters. Depending on the printer that you have and the nozzle size or whatever. Some people might even go to 0.3 if they have, you know, with different materials and different nozzles, etc. The shell thickness, it's the wall thickness. So our models are not gonna, for the most part, not gonna be printed solid. So you might have them completely hollow. You might have them not so hollow, which we'll talk about in a second. But this is gonna be pretty much how thick the walls are gonna be. And you want this to be a factor of the nozzle size, right? So 0.5, 1 is 2.5s, right? So it's gonna do two layers per wall every time it prints, and that's usually okay for me. You can do either 2 or 3 times the nozzle size depending on how sturdy you want your print. I usually just leave it at 1 millimeter. Retraction is whenever the print head is moving around and it's going to change directions or Z or whatever, it's going to pull the filament a little bit to reduce the pressure in there, and that way you won't get a bunch of blobs or, you know, stuff like that. So you definitely want that enabled, and this is going to be a little bit more detailed than what we're going to go into right now. Fill. Alright, so bottom and top thickness, this means the bottom layer and the top layers, right? So as you like, if you can imagine, if this was hollow, this would be a roof, right? And then this would be a floor, let's say. And you want these to be at least 3 to around 6 layer height sizes, right? I usually keep it around 0.6. So when I'm doing 0.2 layer heights, it's gonna do 3, and then, you know, if I'm doing 0.1, it's gonna do 6. It's usually pretty good. You want this to have several layers because depending on the infill that you have, you might get a little bit of sagging in between, and it's not gonna look very nice. But then the next time the layer comes through, it's gonna look a lot nicer than the one before. So you want to have several passes, and of course it also helps with the strength of your model. Then you have the fill density. This is what everybody calls infill, right? And this is basically the percentage of the inside of the model that is gonna be made of your material, right? So 20% infill means 20% of the inside of this thing is going to be PLA, and 80% is going to be air. So this is going to be a big factor on the strength of your model, on the time it's going to take to print it, and stuff like that. So that's a very, very important number. It's also going to determine how much detail you can get out of your print, and combined with the thickness of your shells. Then print speed. This is going to depend on the material that you're using. It's going to depend on your printer. It's going to depend on you know, your settings, your temperature. This is basically how fast the printer is going to be going at the most, right? Because if your model is really small, most printers nowadays do these things called acceleration. So as it moves, it's not going to just like start and go to like 20 millimeters per second straight ahead. It's just going to start accelerating and then decelerating, because otherwise it would be moving really fast and making your printer jerk, and then it would mess your model. So this is how fast it's going to be able to go, period. Most of the time it's not going to get to that fast if you're printing smaller things. But you also want a very small speed if you want to make sure that your layers are adhering, if you want to make sure that you have more control in your model. So I definitely, for my Monoprice Maker Select without mods, I stick to less than 50 millimeters per second, which is what I was recommended by the manufacturer. I usually do between 30 and 40. I'm not in a hurry most of the time, and maybe when I do the Z-axis mod, then I can go faster. But you know, you can tweak this whenever you're doing that. The printing temperature. This is going to depend a lot on your material, because you know, PLA usually goes from 180 degrees to 210. This is Celsius, of course, because, you know, metric is the way that the world does it, and that's what we're going to work on here. Metric for temperature and for length, so just to be clear. And then ABS usually works around, you know, 210 to 240 degrees Celsius. Different manufacturers have different tolerances for their temperatures, and they work a little different. So this is just going to have to be something that you kind of experiment with the brand of material that you use. I find that PLA usually works well for me at 200 degrees. Another thing that temperature is going to factor in is the strength of the layers. So you definitely want to print some calibration cylinders that I'll show you at some other time, and that's going to let you know how well the layers are going to be sticking to each other with the different temperature settings. All right. Print bed temperature. Not everybody has a print bed. For PLA, you don't really need to have a heated print bed. You usually want around less than 60 degrees. You want your print bed temperature to be close, but not at the glass temperature for the material. The glass temperature is the temperature at which the material starts to soften up. So you want to be close, but you don't want to be too close, because otherwise you're going to start to get some pinching down here at the base of your model, and you don't want that. But if you don't have enough temperature here for some materials like ABS, then your print will not stick to the bed and you will have a big spaghetti monster. So keep that in mind. Then let's move to support type. Support types, you can have, in Cura gives you two options. One is everywhere. If you click support everywhere, it is going to find any type of overhangs that you have. It'll try to fill up. Here, let me show you this other. These are the view modes, and then you can have different views here. And I mean, I designed this to have the least amount of overhangs, but the red areas are the areas where you're most likely going to get overhangs. Overhangs, of course, are not a good thing for you, because that means that the filament is more likely to be just hanging off in the air, and it's just going to fall over, and you're going to have really ugly looking prints. So you can see if you're going to have overhangs here in Cura, and then here this is our layer view, and this is basically mapping out all the movements of our print head, and we're going to go into detail a little more later. But as you can see, everywhere supports is giving us support literally everywhere, not only from the bottom here, but also over here in the middle, which we don't always need. We don't really in this case. Then we also have touching build plate, which is just going to build support that is going to be on overhangs that are directly above the print bed. So for example, you're going to get supports for this overhangs right here, but you will not for this circle over here, which is what we want, because these angles are not too steep. So with a good fan, we should be able to handle that easily. Platform adhesion. So you have different options. For FDM printing, you want to make sure that you have a decent adhesion to the print bed. Otherwise, the model is just going to start flopping around. You're going to get a bunch of spaghetti because the layers are not going to stick to each other in the way that you want them, right? So what's going to determine if you have additional methods of platform adhesion, it's going to be your material, right? PLA sticks easier with lower temperatures and to certain materials, and ABS to others. And it's also going to be the area that your model is sticking to the print bed, and other factors. And you're going to have to play around with this a little bit. I find that for most of the things that I do, I don't really need anything. And when I hit none, what it's going to do is it's going to do a skirt. And what a skirt is, and you really do want this, a skirt is just a line or a perimeter around your model. And what this is going to do is make sure that your nozzle is primed and that you're getting some adhesion to the print bed. And once that is done, it's going to start with your model. This is some really small buffer time that is going to be very convenient for you to make sure that nothing's going on and that everything is good to move on to the print bed. So that's the skirt. If you feel like you need a little bit more adhesion, brims are the way to go for me. Basically what it does is, like, imagine you had the skirt and it just keeps going all the way till the edge of your print, and that's basically gonna increase the area that your model is gonna be in contact with your print bed, and that's just going to keep it in touch. This has worked really well for me, as you might see in other videos, probably too well. So yeah, the raft is basically, it's building a bed for your print. Some print beds have holes in them, like screw holes or uneven or stuff like that, and a raft is good for that. But in my experience, having a good flat, solid print bed and different adhesion methods that we'll talk about later, I have never needed a raft, and actually the couple times that I've used them, they've been detrimental. So they take a little bit more material and they take more time, and I really don't really like them. But for the use for let's just use a brim so that you guys can see how that works. Now the filament diameter, you want to make sure you have this, because this is gonna tell your printer. I mean, some printers can't use different diameters, but this is gonna basically be the overall benchmark for your extrusion settings. Your flow, you're gonna use this to adjust for under and over extrusion, which we'll talk about at some other time. And then your nozzle, which is really not gonna change, and you should check what your manufacturer says and use that, or if you change your nozzle to something else, then you're just gonna change it here. Alright, so now let's move to the advanced settings. Really, here you will not be messing with that much right now. This is the retraction settings. You're only going to be messing this if you need a little bit more fine-tuning. The print layer, the initial layer thickness. Initial layers are usually a little thicker to make sure that the print bed gets attached better. You really don't need to be messing with that much. Not really. What I really want to talk to you about here is the cooling. Depending on the type of model that you have, thin tubes are pretty tough on an FDM printer, because the problem is the layer doesn't have enough time to cool down because the print head is like right up on it all the time, and this makes it wobble, this makes it distort, and a lot of things happen. So what you want when you have small layers, you want to make sure that you have enough time for it to cool down, which can be done by either slowing the print head down, or by increasing your cooling fan capabilities, or removing the print head. So what you can do here is like make sure that there's a minimum amount of time that is spent on each layer so that they don't melt with each other. And then here if you have a cooling fan, which you should if you're doing PLA, if you're doing ABS, you don't really need it. Then you can see here, you don't really need to mess with this. If you have a Monoprice Maker Select, One How, Duplicator, Cocoon Create, whatever, and you have the standard fan shroud that comes with it, it's a pretty puny fan, to be honest. So it'll start off, and then at 0.5 millimeters, it'll turn on and you know, help your printer stay cool, whatever. But now I have a way bigger fan and a better fan shroud. So what I'm gonna do is I'm gonna fiddle with it. I'm gonna tell it to not go full fan up until 5 millimeters, and hopefully this will deal with some of the things that I've been messing with. So okay. The one thing that is very important is that once that you have all your settings tuned in, once you have your model positioned the way you want it, you want to make sure that you check your layers. And what you do is you go over here to the view mode, you go over here to layers, and you make sure that the tool path that your extruder is going to follow makes sense, because sometimes it's just some weird little things that that doesn't really make sense to you, or is not really something that you really wanted to do, or sometimes your settings made a corrupted model not print any walls at some point. So you want to make sure that you go through it and that every layer makes sense. You know, we see here that we have our support, we had our brim, this red is our outer wall, green is our inner wall, yellow is our infill, blue is our support, and this dark blue is the path that our tool head's gonna, that our print head's gonna take. And sometimes this is where you're gonna see a little bit of stringing, which we'll talk about later, and stuff like that. So you want to make sure you pay attention to all those details, right? So now you can see we get up here and we get 1, 2, 3 layers, right? Just like we said that we were going to get for the bottom and top. And then we keep going, and everything seems to be good. Now our last print, I did a 20% infill. This time I'm going to try to make it a little bit sturdier, so I'm going to go with 30% infill. As you can see, it is a big difference, and it's going to take a lot more time. So you really, for most things that you're going to do, most likely, you don't need that much infill. It's most likely if you do a lot more, unless it's a piece that's going to be under a lot of stress, you're probably just going to be wasting plastic. This is probably too much right now, but you know, I just wanted to be strong. So yeah, now our layers are all set, and now it's time to save the model. So you can save the model to your computer right here with the little floppy disk, or if you have an SD card, you can plug in your SD card, click here, and it'll save it directly to your SD card. You can eject it from here, and it's really handy for me because I like to use an SD card to print with my Maker Select, because that frees up my computer to do anything else that I wanted to do, and then my printer can just do its thing. I know some people like to connect their computer, but that hasn't been that awesome for me, and I like to do other stuff on my computer. Anyway, that's all for the slicing, and now we're gonna have to move towards the printing. Stay tuned for the next video, and thanks for watching. If you like this or any of my other videos, please check out my GoFundMe campaign. All the proceeds go towards my education. You can click here for that, or if you want, you can do it through PayPal in the description below. Speaking of that, don't forget to check out the description below for relevant links and important details. While you're down there, make sure to leave me all your comments, questions, or suggestions so I can keep making better content for you. Finally, make sure you click that thumbs up and share it with anybody that you think would be interested. And subscribe if you haven't done so yet. You can click over here for other videos and playlists that you might find interesting. See you next time.